Hello everyone. In this video, let's learn Triangles chapter 6. This is a vast chapter. There are 9 theorems with its own proofs. Many questions are also proof based. However, this year this chapter is marked for term 1, and in term 1 exam only multiple choice questions are going to be asked. So for exam point of view, proofs of these theorems will not be asked. However, we need to have a clear understanding of all these 9 theorems. We must be able to apply them and arrive at solutions for the various MCQs. So what I have done is, there are two different videos in which I have explained the 9 theorems, and let's solve MCQs from this chapter in a separate video. So this is part 1, and the topics covered will be comparison of similar and congruent figures, similarity of polygons, basic proportionality theorem or Thales theorem and its converse, similarity in triangles, angle or AA criterion of similarity, SSS, that is side criterion, side angle side criterion. So let's get started. Similar and congruent figures comparison. You would have learnt about congruency in previous years. So congruent figures have the same shape and same size. Both shape and size are equal for congruent figures. Circles with same radii, squares with same side length, and equilateral triangles with same side lengths are all congruent figures. Now, what about similar figures? These figures have the same shape, but their size need not be necessarily same. Mostly the size is proportional and they're not necessarily same sized. So all circles, all squares and all equilateral triangles are similar figures. That is, all circles are similar to each other, all squares are similar to each other, and all equilateral triangles are similar to each other. So here you see there are two circles and the radius of both the circles are same. So these two circles are congruent. We can also say that these two are similar. So circles with same radii are both congruent and similar. Now, if we magnify one of the circles, we see that the shape of the circle is still intact, it is round, but the size has increased. So these two circles are no longer congruent. We can say that these two circles are similar. Radii are not same. The size has increased. So the two figures are similar. Similarly, consider these two squares. Both have equal side lengths. So these two squares are congruent. We can also say they are similar. If we magnify one of these squares, again the shape is retained. It still continues to be a square, but the size is increased. So these two squares are not congruent. However, they are similar to each other. We can see that the size has increased proportionally with respect to the original square. So we can conclude that all congruent figures are similar, but all similar figures need not be congruent. Next, let's see similarity of polygons. Two polygons of the same number of sides are similar if all the corresponding angles are equal, all the corresponding sides are in the same ratio or in proportion. So the angles should be equal to each other and the sides should be in proportion. So let's consider two quadrilaterals, ABCD and PQRS. Both are having 4 sides each. We see that the angles are equal angle A is equal to angle P, both are 105. Similarly, angle. So all the four angles are equal to each other. And if we consider the sides, we have PQ is 3 centimeter and AB is 1.5 centimeter. So we can write PQ is twice AB. 2 times 1.5 will give you 3. Similarly, QR is 5 and BC is 2.5. So QR is 2 times BC. Similarly, we have for the other two sides as well. RS is 2 times CD. SP is 2 times DA. So we see that the sides are in proportion to each other. That is, we can write PQ by AB is equal to QR by BC, which is equal to RS by CD is equal to SP by DA, which is equal to 2 by 1. The ratio of the corresponding sides are all same and it is equal to 2:1. So we can say that the two quadrilaterals are similar to each other. We can write quadrilateral ABCD is similar to quadrilateral PQRS. So similarity is given as this symbol. Next, basic proportionality theorem or Thales theorem. This is the first theorem in this chapter. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So we have a triangle ABC. BC is the base of the triangle. A line PQ is drawn parallel to BC. PQ is parallel to BC. Now, as per the theorem, this line divides the other two sides AB and AC in the same ratio. So, point P divides AB into two parts, that is AP and PB. So, the ratio of the two parts is AP by PB. Point Q divides AC as AQ and QC. Both are in the same ratio, so we can equate both. AP by PB is equal to AQ by QC. So whenever a line is drawn parallel to to one side of a triangle, the other two sides are divided proportionally by that line. Now, what is the converse of this theorem? If a line divides any two sides of a triangle in the same ratio, then that line is parallel to the third side. If we know that px by xq is equal to py by yr, then we can conclude that xy is parallel to qr. So it's the opposite of the previous theorem. Next, similarity of triangles. Now first we saw similarity in quadrilateral with an example. Here let's talk about triangles in specific. In triangle we know we have three angles and three sides. So similarity between two triangles, we will be talking about three pairs of angles and three pairs of sides, corresponding angles and corresponding sides. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. These two are generic conditions for checking similarity between any two polygons. In case of triangles, there are some special features. We know that in a triangle, sides opposite to equal angles are equal. So what happens is in a triangle, when any one of these conditions is true, the other condition is automatically true. So that makes our job easier in case of triangles. When there are two triangles, to check if they are similar, we need not check on all the three pairs of angles and all the three pairs of corresponding sides. Instead, to establish similarity, there are some criterions and we will be learning about them in this chapter. One of the criterion is angle, 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 criterion for similarity in triangles. Other criterion is side, 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 and the third one is side, angle, side. So these three criterions are used to establish whether two triangles are similar or not. First one is angle, angle, angle criterion of similarity of two triangles. Shortly, it's known as AAA, and this is theorem number 3 in the chapter. If in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio and hence the two triangles are similar. In two triangles A, B, C and P, Q, R, if we know that angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R, meaning the corresponding angles are equal, then we can conclude that triangle ABC is similar to triangle PQR. In a triangle, sum of the three angles is always 180 degrees. This is known as angle sum property. So, if two angles of a triangle are respectively equal to two angles of another triangle, then by the angle sum property of a triangle, their third angle will also be equal. So if we know that angle A is equal to angle P and angle B is equal to angle Q, only two pairs of angles are equal, then also we can conclude that these two triangles are similar because automatically the third pair of angles will also be equal. So this criterion has gives the relation between two pairs of angles only. So it is known as AA criterion of similarity of two triangles. If two angles of one triangle is respectively equal to two angles of another triangle, then the two triangles are similar. So we have seen what is AAA criterion and AA criterion. Next theorem is side, side, side criterion of similarity of two triangles. If in two triangles, sides of one triangle are proportional, that is in same ratio of the sides of the other triangle, then their corresponding angles are equal and hence the two triangles are similar. So as per this SSS criterion, it is enough if we know that the three sides are in proportion. If we are sure that the three sides are in proportion, we can directly conclude that the triangles are similar. For example, in these two triangles ABC and PQR, we can see that AB is 2 times PQ, BC is 2 times QR, and AC is 2 times PR. So all the three pair of sides are in proportion. AB by PQ is equal to BC by QR is equal to AC by PR and the ratio is 2:1. So when the three pairs of the sides, corresponding sides in a triangle are proportional, we can conclude that the triangles are similar. This is side criterion. Next, theorem number 5. Side angle side criterion of similarity of two triangles. As the name implies, you have to check for two pairs of sides and the angle included between those two sides. If one angle of a triangle is equal to one angle of the other triangle and the sides including these angles are proportional, then the two triangles are similar. So in this triangle, in these two triangles, we see that AB by PQ is equal to BC by QR, which is again 2:1. So two pairs of sides are given and we see that they are proportional to each other. Also, it is marked that angle B is equal to angle Q. The two sides are proportional and the angle included is equal in these two triangles. So we can conclude that triangle ABC is similar to triangle PQR by side angle side criterion. That's the end of this video. For the remaining theorems and MCQs from this chapter, watch our part 2 and part 3 videos. The links have been given in the description box. Hope you liked this video. Do not forget to subscribe to our channel for more videos on class 10 max. Thanks and have a great day.